Good morning. We continue with the methods of preparation of alkenes. Last class we have discussed by the dehydrohalogenation of alkyl halides. That was the first method for the preparation of alkenes, and we discussed Saysif rule. Okay. Now second method of preparation of alkene is by dehalogenation of dihalides. Dehalogenation of dihalides, or you can say that dehalogenation of vicinal dihalide. Vicinal dihalides. Okay, look at here. What do you mean by vicinal dihalides? Look at here. This is CH3. CH3 is ethane. Now replace one hydrogen atom by a halogen. Here is a halogen, and from here also we are replacing one hydrogen atom by a halogen. Now you can see that these two halogen atoms are in the adjacent carbon atoms. This type of dihalides are known as vicinal dihalides. When the halogen atoms are at the adjacent carbon atoms, that type of dihalides. What do you mean by dihalides? Because there are two halogen atoms, and these two halogen atoms are present on the adjacent carbon atoms. That type of dihalides are known as vicinal dihalides. When vicinal dihalides are heated with zinc in ethanol, or zinc in acetic acid, we get alkene. Okay, this is the another method of preparation of alkenes by the dehalogenation of vicinal dihalides. That means when vicinal dihalide is heated with zinc in ethanol, C2H5OH, heated with zinc ethanol, what will happen is and we get CH2. Here you can see that CH2 double bond CH2 plus ZnX2. Okay, ZnX2. If you take a particular example, you can see that CH2Br, when heated with zinc in ethanol, what do we get? We get CH2 double bond CH2, ethene, CH2 double bond CH2 plus, you can see that ZnBr2. Okay, ZnBr2. Now let us go through the mechanism of this reaction. Mechanism of the reaction. This mechanism is known as E2 mechanism. That means elimination bimolecular. Okay, that is known as E2 mechanism. Look at here, E2 mechanism. So we are taking, so CH, here it is Br, correct? And again C, here it is H, and here it is Br, correct? Okay, now we are treating with zinc in ethanol. You can see that the zinc atom abstract this Br. Okay, that means Br is going with zinc, and this bond is shifting to here. So here it will become a double bond. Simultaneously, what will happen? This bond breaks. This is a concerted mechanism. That means everything happening at a single step. This is a single step mechanism. There is no intermediate. This is a single step mechanism. That means the zinc removes this bromine Br plus. Zinc is removing Br plus, or it is the Br is going with zinc. Then this bond is shifting to here. Simultaneously the bond breaks. Br minus is eliminating. Therefore we get what we get. We get CH2 double bond CH2 plus what will form ZnBr, and here is another Br. You get ZnBr2. Now here you can see that there is a transition state. There is no intermediate, but there is a transition state. What do you mean by a transition state? You can see that in this reaction, you can see that the zinc removes bromine. That means a bond is forming between zinc and bromine. So you can represent like this. This is bond formation, zinc and bromine. Okay, look at it here, and and you can see that. Then this bond is breaking, okay, here it is CH, and here you can see that a double bond is forming, and this is a bond formation, and again you can see that CH, and this bond is breaking. Okay, actually this is the transition state. During this preparation of alkene, you can see that this is the transition state. Okay, now in the transition state, what do you mean by a transition state? The ZnBr, that means this bond is this bond formation. This is bond formation. ZnBr bond is forming, and what is this one? This is bond breaking. BRC bond. This bond is breaking, and what is this one? This is bond formation. This bond is forming. This new bond is forming here, and what is happening here? This bond is breaking. This bond breaking. Clear? So look at it here. You can see that ZnBr, this bond is forming. That's where BF, the bond is forming. And you can see that this bond is breaking. So BB bond breaking. This bond is breaking. And you can see that here is a double bond is forming. Second bond is forming. That means this is bond formation BF. And you can see that this bond is breaking. Again, this BR is breaking. This is the transition state. And after the transition state, you get this product. That means E2 mechanism means this bond formation, this bond breaking, this bond formation, this bond breaking, everything happening in a single step. Therefore, it is known as elimination bimolecular. Okay, this is the mechanism of E2 mechanism. This is E2 mechanism. Now, stereochemistry of the reaction. Stereochemistry. Stereochemistry of the reaction. Okay, here you can see that there are two types of elimination reaction. One is syn elimination. Okay, what do you mean by syn elimination? Look at it here. You can see that syn elimination means here it is H, and here it is Br, and the second molecule I am taking again Br. Here it is H. This is a Sohor's projection formula. You can see that in syn elimination, the zinc removes this bromine. Okay, and what will happen? This bond will be shifted to here, and okay. That means we can see that both the bromine atoms, both the substituents are removed from the same side of the carbon atom. This is our CC bond. From the same side of the CC bond, both the atoms are removed. That means in this case we get what do we get? CH2 double bond CH2 plus what will form ZnBr2. So here you can see that in syn elimination, both the bromine atom, both the halogen atoms are removed from the same side of the CC bond. So this is our CC bond. From the same side of the CC bond, both the bromine atoms are removed. That type of elimination is known as syn elimination. Now second one is anti-elimination. Anti-elimination. What do you mean by anti-elimination? Look at it here. Here it is H, and here it is H. Here it is Br. And now you rotate this molecule. You can write this. You might have studied. It will come like this. Okay. This is eclipsed and this is staggered. And here you can see that H, and here it is Br. Now you can see that the zinc removes this bromine. Then what will happen? This bond will be shifted, and this bond is breaking. We get CH2 double bond CH2 plus ZnBr2. Here what is happening? The bromine atoms are removed from the opposite side of the CC bond. Here it is our CC bond. The substituents or the halogen atoms are removed from the opposite side. That means one bromine is here and the other bromine is here. If this way it is removing, then it is known as anti-elimination. So this is the stereochemistry of dehalogenation. One is syn elimination. In syn elimination, both the halogen atoms are removed from the same side of the CC bond. From the same side of the CC bond, that is known as a syn elimination. And in anti-elimination, the halogen atoms are removed from the opposite side of the CC bond. Opposite side of the CC bond. Okay, that's all about dehalogenation of vicinal dihalides. And the last method of preparation of alkene, dehydration. Dehydration of alcohols. Last method, dehydration of alcohols. Dehydration. What do you mean by dehydration? Removal of water molecule. Dehydration of alcohols. Okay. When alcohols are heated with concentrated H2SO4, when alcohols are heated with concentrated H2SO4, will undergo dehydration and will give alkene. So alcohols, example CH3, CH2, OH is heated with concentrated H2SO4. Concentrated H2SO4, we get CH2 double bond CH2 plus H2O plus H2O. Okay, look at here how you can write CH3 can be written as CH2H and this CH2OH. CH2OH, what will eliminate? H2O will be eliminated and what we get? This bond is, okay, you get CH2 double bond CH2. Okay, another example, if this is your alcohol, CH3, CH, single bond, CH3, CH2, CH2OH, what we get? On treated with concentrated H2SO4, what we get? You can see that this can be written as CH3, this CH2 can be written as CHH and CH2OH. Okay, water molecule will be eliminated and you can see that what we get? We get propene, CH3, CH, double bond CH2. Okay. What is this one? This is propene. This is what is known as a dehydration of alcohol. Dehydration of alcohol. Okay. When alcohols are heated with the concentrated H2SO4, will undergo dehydration and will give alkene. The ease of dehydration, that means tertiary alcohol, then secondary alcohol, then primary alcohol. That means this tertiary alcohol and secondary alcohol will undergo dehydration in presence of dilute H2SO4. But primary alcohol will undergo only in the presence of concentrated H2SO4. That means this is the order of dehydration, ease of dehydration, tertiary alcohol, then secondary alcohol, then primary alcohol. Okay, thank you. We continue in the next class.